Hello, I am Chandra Jonifar, a graduate student at Salmon University. I am very pleased to be able to present my paper at the International Conference on Technology and Innovation for Human Life, taken in 2023. In this presentation, we will discuss the topic entitled Pre-trained Network-Based Transfer Learning for the Prediction on Tire Condition. Introducing the author, Chandra Zonifar, with Department of Computer and Electronic Convergence Engineering, Salmon University affiliation, take by Salmon University, and Professor Jong Dong Kim, Department of Computer and Electronic Convergence Engineering, Salmon University, Department of Computer Science and Engineering, Salmon University, Genome-Based Bioenergy Convergence Institute, Salmon University, Republic of Korea. The presentation section consists of: first is the background research on tire prediction with deep learning approach, so also about deep learning, and then what we explore in this study, that is use transfer learning for predict tire condition based on image, and last but not least, experiment and result. So, tire failure is the last thing a driver wants to encounter when driving a car at high speed, but it's also the most difficult to prevent. So, as one of the most important part of vehicle, defects such as small pits and slight crack on the tire's surface, so may cause major traffic accidents, and even directly even the driving safety on the vehicle. So tire quality guarantees the normal driving of the car. Tires are very important, but few drivers regularly monitor their condition. Drivers are aware of the risk of improper inflation, but continue to use vehicle with underinflated tire. So using an automatic visual tire inspection system will increase driver awareness to proper tire change time, so reducing the risk of sudden separation of tire material. So in this study, we use computation and deep learning algorithm to predict tire condition based on image. Let's start with a brief discussion about deep learning. Deep learning is a revolutionary approach in the field of AI that allow computer to learn independently from very large and complex data. So deep learning is able to recognize and understand complex patterns in data and enabling accurate decision making, also precise prediction. So from deep learning, I want to go to convolutional neural network, or CNN. CNN is type of architecture in deep learning, specifically designed for processing visual data such as image and videos. By using CNN and pooling layer, CNN can effectively extract important features from visual data and learn complex features. Transfer learning. Transfer learning is a technique in deep learning in which knowledge that has been learned from one task can be used to improve the performance of a model on new tasks or prediction, for example. So by using transfer learning, model can leverage previously learned feature representation for similar tasks. So this is useful when we want to apply a model to a new task without having to train it from scratch. ResNet, Residual Neural Network. ResNet is a convolutional neural network architecture. So in ResNet is the use of residual blocks which allow the model to more effectively train deeper network. So residual blocks address the challenge by integrating shortcut connection which allow information to flow directly through block without going through a series of layers. So In this tire prediction study, we explore various ResNet and DenseNet models to classify tires into two different classes: cracked tires and normal tires. So we have to compare 5 models, including the ResNet 50, ResNet 101, ResNet 152, and also DenseNet 121, DenseNet 169, DenseNet 201. To verify the model that we analyze, we use a public dataset that has a total 1028 data, where the number of crack class is 573 and normal tire are 491. And then we use 80% for the training set and remaining for the testing. So for the experimentation, the model training for the tire prediction has been carried out with TensorFlow 2.5.0 package on Ubuntu operating system using an Intel Core i10, Intel Core i9, and 62.7 GB RAM, and the graphic card used is NVIDIA GTX 1080. So in our experiment, we use two scenarios, where the first scenario is to run the training using the various model without using transfer learning, and the second scenario is to apply the pre-trained model to the model. To verify whether the model being analyzed has good performance, we use accuracy metrics. The accuracy score is carried out according to the rule where the sum of true positive and true negative is divided by total of the sum of true positive, true negative, false positive, and false negative. So we get a result where the DenseNet 121 model that is applied transfer learning produce high accuracy of 0.9515, better than the other models. So it means the model we analyze managed to predict tires into two classes very well. So this proof in the case of tire prediction image base that the concept of fine-tuning CNN models with transfer learning can improve predictive performance that is more accurate. Also, we can see on the graph, the red lines and accuracy validation show that the model learn well. But however, this study has limitation to be complete in the future research, such as the model was built only to recognize normal and correct tires, where in the real world condition of tire defect are diverse and complex, such as air bubbles, foreign bodies, and so on. Well, this is my final slide. So during this presentation, we have discussed the potential deep learning method in the field of image classification, specifically tire prediction. Thank you for your attention.